Hello, this is Mr. Henry, and welcome to lesson 4.8, Finding Slope and Rate of Change. So the essential question says, how do I find the slope of a line and interpret slope as a rate of change? Okay, so there's two kind of goals in this lesson. For a warm-up, it is a type 1 and 2 minutes on the clock. It says, give your own personal definition for the word slope. So if you know a good mathematical definition, you can put that. If you don't know a mathematical definition, if you hear the word slope in a sentence, what do you think of? Put down your own definition. Simple as that. Pause the video, take 2 minutes and do it. When you're ready, move on to the vocabulary. Hit play, and we'll move on together. Slope. Slope is how slanty a line is. And it's found using this formula, m equals, and it's the change in y over change in x, but most people, when you're talking about the slope, they just remember m equals, and it's here, I just don't like the way it's written, y2 minus y1 over x2 minus x1. Okay, so this is figuring out how slanty the line is. Is the line really steep? Is it kind of more almost flat-ish? Is it going up like these two? Or is it going down like that one? Is it perfectly flat? Is it straight up and down? This equation can tell you all of that. And that it will become extremely important when we're talking about the slopes of lines or the equations of lines, because one of the best ways to describe a line is using its slope. The other vocabulary word we have here is rate of change. A rate of change compares the change in one quantity to the change in another. So it could be the amount of money spent versus time. It could be comparing any two quantities together is a rate of change. How one thing changes with respect to another. So let's get right to it. The first problems we see here, it says finding the slope of a line. So we're going to find the slope of the line going through these 2 points, and we're going to use that slope formula. That slope formula is one of those formulas that you should probably remember. I believe they're going to have it for you on the formula sheets on PSSAs provided to you, but it's one of those formulas that's going to be used quite a bit, especially over the next, the rest of this module and into the next module as well. And for people expecting to go to higher levels of math, trigonometry, calculus, algebra 2, geometry, those sorts of things, this slope formula is used quite a bit there as well. So the slope formula starts with m equals y2 minus y1 over x2 minus x1. By the way, I do recommend you write down the formula each problem. It helps you remember it better. So we're going to take these points and plug them in here. You go, well, how? How do you know what's the y2 and the y1, this x2 and the x1 thing? It's pretty easy. This is the first point on the piece of paper, so I'm going to call this point 1. And this is the second point, so he's point 2. Now, this, if you remember your ordered pairs, the first number in the ordered pair is the x coordinate. So this is the x coordinate of point 1. So this would be the y coordinate of point 1. So x1, y1, x2, y2. It's as simple as that. Now all you do is you take and you plug these points in to the formula. So y2 is negative 4, y1 is 4, x2 is 0, x1 is negative 2. And yes, you do still need the minus negative 2. So it's a minus here, and it's a negative 2 there. You simplify, and you get your answer. Negative 4 minus 4 is negative 8. 0 minus negative 2 plus a positive is positive 2. And that divides down to a negative 4. So the slope of this line is negative 4. Now, nothing else I can tell you because I know how the slopes look. The slope would look something like this. Well, I can't guarantee it's going through that point, but it's going to be a really steep downward line. I know it's downward because it's negative, and I know it's steep because 4 is it's a pretty big slope. Letter B. Same thing. M equals y2 minus y1 over x2 minus x1. So I'm going to label my points x1, y1, x2, y2. y2 is 1 minus 7. x2 is negative 2 minus x1 is 3. Simplify. 1 minus 7 is negative 6. Negative 2 minus 3 is negative 5. And I can just simplify the signs here, and this becomes a positive 6 over 5. Now, one thing to mention about slope while we're here, it's important. You want the slope to be a fraction. Most of the time, you do not want the slope to be a decimal. It would not be good for me to say, oh, this is the slope of 1.2. Okay, this is not as good as this. Or other way around, this is not as good as the fraction. You actually want the slope to be a fraction, and it'll make more sense when we start talking about the graphs of the lines further down in another couple examples. But you actually want the slope to be a fraction because the fraction tells you how this line looks. I can tell you right now what this line looks based off of that fraction. If you gave me a decimal slope, I'd have a much harder time. I know that this slope, wherever it starts at, it is, I'm going to go up 6 over 5. And then up 6 more and over 5. So whatever the line looks like, I know that the slope is something along that line. If you said the slope is 1.2, I could probably make an educated guess, but it wouldn't be as accurate as saying that. So leave it as a fraction. That means no mixed numbers. I'm not going to change this into 1 and 1/5. No decimals. Improper fractions are fine. Just simplify the fraction as much as possible, but leave it as a fraction. I'd like you to please try these two. Use your slope formula, write it down, fill in your numbers, simplify, and you're done. Go ahead, pause the video. When you're ready to continue, hit play, and we will go through it together. Alright, so let's see. Not y equals, m equals. M equals y2 minus y1 over x2 minus x1. This is point 1, so x1, y1, x2, y2. And now we plug in our points. Negative 1 minus 8, negative 3 minus 9 gives us negative 9 over negative 12, which simplifies down to 3 over 4. And that's our slope. Another thing I want to mention here, since we're talking about slope, and it's good to know all the little details, it actually doesn't matter if you call this point 1 and that point 2. If I would switch these two, and I'm going to show you here, if I would call this x1, y1, and x2, y2, I'm actually still going to get the same answer. I'm still going to get 3 over 4. Watch. y2 minus y1 over x2 minus x1. So if I plug in the points from here, y2 is now 8 minus negative 1 and 9 minus negative 3. 8 minus negative 1 becomes a positive 9. 9 minus negative 3, keep flip change, becomes a positive 12 and simplifies down to 3/4. So we got the same answer both ways. But typically, I just use this is the first point, this is the second point. It helps out. Letter D, y2 minus y1 over x2 minus x1, m equals. All right, and so x1, y1, x2, y2. 4 minus negative 2, 5 minus 2. These types of problems, it's really important to know your integer math pretty well, your adding and subtracting especially. 4 minus negative 2, keep, flip, change, becomes 6. 5 minus 2 becomes 3, and that equals a slope of 2. So the formula is not too bad. Once you get the hang of it, it's pretty quick, pretty easy. I typically find that students mess up a lot on those because of the signs. Like, they'll just make little sign mistakes. Instead of using a calculator to help check their math, they're so confident in themselves, they just say, oh, -1 minus 8 is -7, and they get some really weird fractions. Because fractions are fine, they think the answer is correct. If you're in that situation, it doesn't hurt to take 5 extra seconds, plug it into a calculator, -1 minus 8, and see that it is -9. Okay? Example B. Now we're looking at what happens, or how do you find the slope of a line from a graph? Well, there's actually two ways we can do this. One way is easy. One way is harder. I'm not going to call it hard, it's just harder. The harder way is using the formula we just did. So let's do the harder way first. So what we need to do is we look at our graph, and we need to find two well-defined points. Points where the line is going right through an intersection, where you can guarantee you know exactly what that point is. So I see a couple on my graph. All of these points, I could guarantee I know exactly what that point is. This is the point 1, -2. 3, -1. 5, 0. So you only have to find 2 points, well-defined points. It would not be good for me to pick like this point right here, because I can't get, I can know it's -1, -2, but I don't know exactly where the up and down, the y coordinate of that location is. Okay, so you pick points that go right through an intersection, so you can guarantee you know what the coordinates are at that location. So I'm going to pick 2 of these. It doesn't matter which 2. I'm going to pick this guy and that guy, just because. So this one has the coordinates of 1, 2, -3, comma 1, 2, 3, -4. This point has the coordinates of 1, comma -2. And we're using the slope formula. So that same formula we did before, m equals y2 minus y1 over x2 minus x1. And the same thing as before, you can go, well, how do you know which one's point 1 and point 2? Doesn't make a difference. So I just call this guy x1, y1, x2, y2, and we go to town. -2 minus -4 over 1 minus -3. You can check my points and verify that I plugged them in correctly. I think I did. -2 minus -4 over 1 minus -3. Yep. And minus a negative becomes a plus. -2 plus 4 is 2. 1 plus 3 is 4. And that simplifies to 1/2. So the slope of this line is 1/2. That is the harder method. Now, the easier method only works if you have a graph. I'm going to erase some of this other stuff. I'll erase it all and I'll put some of it back. Now, you still need to find some well-defined points. These points where you guarantee you know where the line is. So all you do is you look for the directions that you would follow to get from one point to the next. So from here to here, I would go up 1 over 2. Listen to what I said. Up 1 over 2. Slope. If you went from one point to another point further away, you might go, I'm going to go from here to, I don't know, here. I would go up 1, 2, 3, 4, up 4, over 1, 2, 3, 4, 5, 6, 7, 8. Up 4 over 8, which as a fraction simplifies down to 1/2. Now the reason why this works is because when you're doing this y2 minus y1 stuff, what you're doing, this top part here, is finding the change in the y value, the up and down. So from this point here to that point there, you're going to go up 4. So this top number, the change in y, is 4. And this bottom number is how far you'd go sideways from one point to the other. And from this point here to this point here, you'd go sideways 8. So that's why this is the same thing. So when you have a picture, you can merely, I call it counting boxes. You can count the boxes and just find the slope if you have a picture. I can go from here to here, up 1 over 2. That's my slope. It's always the y over the x when you're talking about slope. Change in y over change in x. Up 1 over 2, that's your slope. All right. So for the second problem here, I'm going to do the easy way first, and then I'm going to do the formula way second. So the easy way is I'm going to find 2 points. I see one here and one here. In fact, those are the only 2 I see. Now, for me to get from this point to that point, change in y over change in x. How far up and down, how far sideways. So I'm going to go down 1, see, down 1, over 1, 2, 3, 4, 5. The slope is going to be a negative 1/5. It's negative because I'm going down 1 over 5. And just so we're aware, this is something my students mess up sometimes, is you always, when I'm talking about going over, I'm always going over to the right. Up 1 over to the right. When you read a graph, you read it like a piece of paper. We read paper from left to right. You read an equation from left to right. Well, you read the graph from left to right. From left to right, this graph is going up. There's a little ant crawling across here. He'd be going uphill. If there's a little ant crawling across here, he'd be going downhill. So down gives you a negative slope. Up gives you a positive slope. Oopsie, I wanted that negative 1/5 back. Now, we did this using the graphing method, just counting boxes. Let's do the formula method. So y2 minus y1 over x2 minus x1 is my slope. This is the point 1, 2, 3, 4, negative 5, comma 1, 2, 3. And this is the point 0, comma 2. And y2 minus y1 over x2 minus x1. You can check and verify. I used x1, y1, x2, y2. And if I do my math here, a 2 minus 3 is negative 1. A 0 minus a negative 5, which turns into a plus, is positive 5. And would you look at that? We got the same answer. We have the same slope. So that slope is telling us how slanty the line is. You go from one point to the next, down 1 over 5. Letter C. I'm going to start by finding some of these well-defined points. I count 3 of them. 1, 2, 3. I know exactly where those points are, the coordinates of those points. Now, I'm going to do the easy method first. To get from one point to the next, and you can pick any two, I'm going to go down 1, 2, 3. Down 3 over 1. So my slope is going to be negative 3 over 1, or a slope of negative 3. Using the formula, I'm going to use these other 2 points just to show it's the same slope between here and between here. So if this had a slope of negative 3, I'm going to show that this also has a slope of negative 3. This is the point 2, 1, and this is the point 3, negative 2. Write down the slope formula. x1, y1, x2, y2, negative 2 minus 1 over 3 minus 2 gives me negative 3 up top, 1 down below. We got the exact same slope. This line, everywhere on this line, has a slope of negative 3. Even if I would have picked this point here, change color. If I would have picked this point here and this point here, and I used the slope formula where I counted boxes, I'm going to find the slope is negative 6 over 2. Down 6 over 2, which, if you would reduce that fraction, reduces to negative 3 over 1. So every point along the line has the same slope. What I'd like you to do is I'd like you to please do letter D. Use both methods. Use the slope formula and use the counting boxes method to verify your slope. Go ahead, pause the video right now, do it on your own. When you're ready to continue, hit play, and we'll go through it together. Okay, so we have that's well-defined, and that's well-defined, and that's well-defined. So I found 3 points that are well-defined. I know exactly what the coordinates are of those points. I'm going to do the formula first this time. So I'm going to pick this one and that one. So this has the point negative 1, 3. This has the point 1, 2, 3, 4, 5, 6, 7, 1. So m equals y2 minus y1, x2 minus x1. X1, y1, x2, y2 gives me 1 minus 3 over 7 minus negative 1. Gives me a slope of negative 2 up top, and keep, flip, change 8 down below, which is negative 1/4. So from one point to the next, you would go down 1 over 4. That's what this is saying. Now let's verify that using our counting the boxes method. Get from one point to the next, I would go down 1 over 4. It's down because it's negative. So I'd go down 1 over 4. 1, 2, 3, 4. It worked. And I can repeat that process. Down 1 over 4. So that is the slope of that line. Down 1 over 4, or negative 1/4. I have 2 more of these for you to try. Go ahead and do them right now. Okay, so the first one, we have a whole bunch. In fact, every time it's crossing here, it's at a well-defined point. So this one's going to be pretty easy to pick 2 points for. So this one I'll do the graphing method first, just counting boxes. So pick any 2 points, count the change between them. So I'm going to go from here to here. Why not? So from those 2 points, I'm going to go up 1, up 2, up 3, because it's up, it's positive, and over 1, 2, 3. So a slope of 3 over 3 equals 1 over 1, or just a slope of 1. So that is the slope of this line found graphically by counting boxes. Now to do this using the formula method, I'm going to pick 2 other points. I'm going to pick this point and this point. So this point has the coordinates of 0, 1, 2, 3, negative 4. This has the coordinates of 3, negative 2. M equals y2 minus y1, x2 minus x1, x1, y1, x2, y2, giving me negative 2 minus negative 4 over 3 minus 0. Keep, flip, change, gives me 2 over 3. I see my mistake. This is not 3. I miscounted here. It's a 2. It's over 2 down 2. So that would make that a 2 here, make it a 2 here, and a 1 there. So we did get the same slope. Slope of 1 graphically using the counting boxes and using the formula. And finally, letter F. Let's see, I've got well-defined point there, there, and there. I'll do the formula method first. I just keep trying to switch it up a little bit just to show you it doesn't matter which way you do it. It's the same thing. So I'm going to use the formula method first. I'm going to pick this point and that point. Why not? So this one's easy, 0, 0. And this is the point 1, 2, 3, 1. M equals y2 minus y1 over x2 minus x1. M equals x1, y1, x2, y2. And so we have 1 minus 0 over 3 minus 0, which is 1 over 3. That was pretty easy. Counting boxes, get from one point to the next. I'm going to use here. Actually, I'll use the same 2 points this time. So from here to here, I'm going to go up 1 over 3. And up 1 over 3 gives us a slope of 1/3. So again, we got the same thing, both methods. So that is how you find slope. The next page is just a little summary. It says, in your own words, what is the slope of a line? And what are 2 methods for finding the slope of a line? If you could, please pause the video and do it on your own right now. And when you're ready to continue, hit play. We'll go through it together. Okay, so let's see. What is the slope of the line? Well, the slope of the line shows you how slanty the line is. It tells you if the line is going up, if it's positive. It tells you if the line is going down, which is negative. And we didn't talk about the other 2 or see the other 2, but if you have a horizontal line perfectly flat, it has a slope of 0. And if the line is going straight up and down, you eventually, when you do the slope formula, you get 0 divided by 0, which doesn't work, or something divided by 0, which doesn't work. So this is an undefined, or has no slope, or undefined. So apart from telling you if it goes up, down, flat, or up and down, it also tells you how steep it is. So this line of 1/2 was not very steep. If we had a slope of 2, it'd be much steeper. Slope of 3 would be even steeper, and 4 would be steeper. Now, these are not accurate, but the bigger the number, the steeper, the more up and down the slope is. And it's even true for negatives. This one had a slope of -3. That's pretty up and down. A slope of 4 would be even more up and down. A slope of -2 would be less up and down. So the slope of a line tells you how slanty it is, and also tells you the direction it's pointing. And then what are the two methods for finding the slope of the line? Well, you can use the slope formula, this m equals y2 minus y1 over x2 minus x1, or you can, if you have a graph, you can count the boxes. And remember, it's always the change in the y over the change in the x. So the up and down over the sideways. Example 3. Finding a rate of change. It says a computer cafe charges you for using the internet. The table below shows the costs. Graph the data on the graph provided. Find the change in cost with respect to time. Okay, so the first thing it said to do is graph the data. So we have a little chart here for us in our graph space. So I'm going to do that. So time of 14 minutes, cost of $7. So 14 minutes, let's see, this seems to be counting by 4s. So that's 4, so that would be 12. So 14 minutes would be here. And this is also counting by 4s. So $7 would be like, I don't know, here-ish. Okay. 20 minutes would be here. $10 would be halfway. So 20, 10. 32 minutes. Okay, that's right here. And $16. 40 and 20. 20 would be here. Okay, so I have a little graph. And if I would connect these points together, let's see what they form. I mean, obviously it forms a line, but let's see how it looks. Okay. So we have a line that goes through the origin. And let's see if that makes sense. I mean, if you're on the internet for 0 minutes, wouldn't it make sense that they're going to charge you $0? I'd hope so. So this is a proportional relationship. If you remember those proportional relationships from before, that's what this is. It's a proportional relationship. So graph the data provided. We did. Find the change in cost with respect to time. We're going to do this two ways. The one way we're going to do this is using slope, the slope formula we just did. So this is our x variable, y variable. So I'm just going to pick 2 points. I'm going to use this as my first point, so 14,7. And this is my next point, 20, 10. So x1, y1, x2, y2. So my slope formula, hopefully you're starting to remember it by now, gives me 10 minus 7 over 20 minus 14. That's a 3. That's a 6. Simplifies down to 1/2. Okay, so the slope here is 1/2. That's the slope of this line. It's 1/2. Now, I also mentioned that this is a proportional relationship. It is. All those other proportional relationships, it went through 0, which this does. So I'm going to use a proportion as another way to show the relationship between the time and the cost. So remember we did this before. We picked one of these points. We said, okay, so time, cost. And so if the time was 14, the cost was 7, and then just our random general variables x and y. If we cross multiply this, we get 14y and 7x. If we solve for y, as we typically do in these problems, divide by 14 on both sides, y equals 1/2 x. this number right here is the same thing as that. And it's not a coincidence. It's not just, oh, look, it's magically both equal to 1/2. No, it's that way on purpose. This is the relationship. So for every minute, for every X value you put in, every unit here you put in, so if you're there for 1 minute, they're going to charge you half of $1. If you're there for 10 minutes, 10 times a half is $5. So there is a relationship between the slope of the line and the rate of change. It's the same thing. The rate of change for a proportional relationship is the slope of this line. So the bigger the slope, if I had a slope that was much higher, let me draw another line here. So if I had a bigger slope, I would have a bigger rate of change. It'd be changing faster. Every 10 minutes would cost you more money because it's a bigger change. The slope of the line and the rate of change are the same thing. Find the change in cost with respect to time. The change in cost with respect to time is 1/2. 50 cents for every minute. That's what we found. One last thing to point out here is that this slope, and so this is the slope, this is the slope. This slope is a unit rate, meaning for every 1 minute, if I'd go 1 minute here, I'd go up 50 cents. Another 1 minute, another 50 cents up. Another minute, another 50 cents. Another minute, another 50 cents. Slope is a unit rate. All right, let's see another example. Now this one I'm going to have you do mostly on your own. It says, at Sam's Club, you could buy 10 ounces of green beans for $1.50. If the cost of green beans is constant, which means proportional, estimate how much it would cost for 35-ounce can of green beans. And I give you a graph space here. So go ahead, make a table, graph it, go ahead and do the problem. When you're ready to continue, hit play, and we'll go through it together. All right, so I would start by making a little table. So X, Y, and the X variable would be the amount of beans. And then the cost would be the Y variable. Because the more beans you add, the higher the cost, not the other way around. And so now I can just come up with some X and Y values to plug into my table. So let's see here. So if we just put in, say, like, I don't know. Well, we know it says here 10 ounces is this much. So I can even just plug that in. I know 10 ounces is $1.50. And if I graph it here, ounces 10, $1.50 is here. I know that 0 ounces will cost me $0. If I don't buy a can of green beans, it's not going to cost me any money. So I know that point is right here. And with those 2 points alone, I can make a prediction, an educated guess, along those lines. I bet every other point was going to fit along that line. Now it's asking for how much would it cost for a 35-ounce can of green beans. So we can't really use our graph because our graph doesn't go to 35 ounces. It only goes to 20 ounces here. So for me to go to 35 ounces, I've got to do a little bit more. Well, I can find the slope of this. I mean, I have 2 points, so let's do that. So I have the point 10, 1.50 and 0, 0. Slope is y2 minus y1, x2 minus x1. This is going to be my x1, y1, x2, y2. So that gives us 0 minus 1.5, 0 minus 10, which is negative 1.5 over negative 10, and that simplifies down to a positive something, 1.5 slash 10, it's going to be 0.15, yeah. So 0.15 over 1. That is not a pretty slope. It's positive, but it's not a pretty slope. But it's still a unit rate. That tells me something. That slope being a unit rate means for every dollar, I'm getting 0.15 ounces of beans. Well, if that doesn't make much sense to you, and it doesn't seem to make much sense in the problem, we could also use a proportion because the relationship was constant, as it said so in the problem. It's constant, which means it's proportional. So we could say beans over cost. Well, if you could buy 10 ounces of beans for $1.50, how much is it for 35 ounces of beans? Ah, this is making a bit more sense now. So if we cross multiply here, 10x, and then clear, 1.5 times by 35, 52.5, divide by 10 on each side, x equals 5.25 dollars. So it would cost $5.25 to buy a 35-ounce can of green beans. So we know how much the green beans cost. I just want to do a little bit more explanation just to help out understand a little bit more. Makes things a bit more clear. Yes, this method works out very nicely. This seemed to be kind of a dead end for us, but this is not completely a dead end. As I was mentioning before, this is a unit rate, meaning for every dollar you spend, you get 0.15 ounces of green beans. Let me rephrase that because the top variable here is the cost, the dollars. So for every ounce, it's 0.15 cents. So 1 ounce costs you 15 cents. We could make some predictions from that. If 1 ounce is 15 cents, we can keep going and say, well, 2 ounces would be 30 cents. And 4 ounces would be 60 cents. We're taking the number of ounces times by 0.15. So for us to go from here all the way down to 35 ounces, all we'd have to do is take 35 times by 0.15, that unit rate. And I guarantee you it's going to equal 5.25. Okay, so this idea of finding the slope, it wasn't a complete dead end. It didn't make sense at the time, but it is another method for doing the same problem. This is telling you how much it costs for 1 ounce. So if it's 15 cents for 1 ounce, 35 times that amount is $5.25 for 35 ounces. Okay, so just another way of doing the same problem. Alright, so for our summary here, we have a type 1, 2 minutes on the clock. It says, how are slope and rate of change related? So throughout this lesson, we've talked a lot about slope, a lot about rate of change. How are those two concepts related? How are they connected? Go ahead, pause the video, answer the question, and this has been lesson 4.8. Thanks for watching.